So class, let me, okay. So are you hearing, are you seeing my slides, class?
Yes, doctor.
Good. Okay. Actually, we'll discuss regarding this example today, and um, then we'll finish. Before that, I would like to tell that please refer back to your ebook also, whatever I have given. Please open page number 218. I can actually also, because two things I cannot show you. Please open your textbook, page number 218. Before starting that, I would like to inform that here I have found some errors also in your textbook. So class, uh, uh, please follow my whatever we will calculate now. You follow this method only. Ignore, because I have seen that some mistake is there. So first mistake, first, if you see, as I told that in your textbook, uh, example 2, uh, uh, you see that it is written that Coke produced, Coke produced, the figure is given 29,813 pound per hour. See here, see that the unit pound per hour, it means that is already mass flow rate, right? So, so here the word itself is wrong. So here, that is why you have to you write like as I mentioned here, that mass flow rate of Coke is 29,813 pound per hour. Class, is it clear so far to you? Class?
Can you repeat, Prof?
Yachinta, okay. Uh, the the textbook is mentioned that Coke produced equal to 20, data is given like that, that Coke produced, if you see that in your textbook 218 page number for this example, here is mistake. So mistake or error is there. So it's given that Coke produced equal to 29,813 pound per hour. Actually, it, since it is pound per hour, so we can mention that it is actually not weight of Coke. This is a mass flow rate of Coke. Okay, so correct accordingly as I mentioned, mass flow rate of Coke equal to or is 29,813 pound per hour. This is first error. Second error, let me maybe better. I will show you first that example. Uh, okay. See, are you seeing me now? The textbook I opened for you, class.
Yeah, we Yes, can. doctor. We see.
Okay, good. See here. See here. Mentioned that Coke produced is this. Actually, here you write or actually this data will be given, that is a mass flow rate of Coke equal to this one. Okay, right there. Secondly, to do this calculation, some data will be given like that. Heat of combustion of Coke, delta Hc, will be given as it is. Here, see, Cp stands for heat capacity. Heat capacity of catalyst is given, will be given like that. heat capacity of air. Cp stands for heat capacity. Heat capacity of air is like that. Heat capacity of nitrogen also will be given, heat capacity of carbon dioxide, and heat capacity of coke 21.1 kilojoule per kg Kelvin. One thing I would like to draw your attention here. See, here all the heat capacities are given, but see the unit. See here, for heat capacity of catalyst, unit is given kilojoule per kg times Kelvin, but for air, see here given kilojoule per kilomole per K. For nitrogen also, see here mole, number of moles is given instead of weight, kilogram. On the other hand, for when it is given Cp value of coke, it is given kilojoule per kg per Kelvin. So meaning that their heat capacity is given for different substances in different unit. If like that, actually here calculation will do the find the catalyst circulation rate. Catalyst circulation rate, we can, in other word, we can say that catalyst mass flow rate. Mass flow rate we will calculate for catalyst. Yesterday I have shown you the configuration. Do you remember? I think so, right? There is a each side by side configuration, that meaning that first the reactor, and side there is a catalyst regenerator.
Regenerator.
Exactly, very good, thank you. So the catalyst will be continuously regenerated. So meaning that continuously circulated. Spent catalyst will be goes to from reactor to regenerator, and regenerated catalyst will be enter from regenerator to reactor, right? So that is why we have to find the catalyst circulation rate or catalyst mass flow rate we have to find. For doing this calculation, we will use this formula, heat balance, to do that heat balance. Please, here I want to draw your attention. We will, please note down in your exercise book. We will use equation 8.18. Since Cp value, I have informed you, it is given in different unit. So here also, if you put like unit heat balance equation put like that, it is you cannot find the mass flow rate in kg in kg per hour. So here also we have to edit. I have found some error in here equation. Actually, we will follow this equation, but here is some error is here. So the correct equation I have given in slides, which I will show. In reference, you write in your, because I cannot show two screen at a time. So first you write this equation. Everyone, please write this equation. I'm giving 1 minute. Then because please write. Then I will. It will be easier to me to make you understand. Please write this equation first. Heat balance equation. By using this, we have to find this one, M4, the mass flow rate. Are you writing, class?
Yes, doctor.
You write first as it is first. But keep in mind that there will be some correction. Okay. Can I proceed?
Yes.
Okay. Now, then I have to is. Are you seeing my slides now?
Yes, doctor.
Okay. Now the corrected equation you write here on the bottom. Corrected equation as it is. You write first. Ignore just now whatever in the book I have given and write as it is now. It is in the bottom. You write first, then I will explain why, where is the mistake is there in the or error in the book itself, the equation. Are you writing? Class, are you writing, Ariana? Manjula?
Yes, doctor.
Is it clear so far what I have until now?
Doctor,
Uh,
the equation right, M catalyst, heat capacity catalyst in bracket TR spent, doctor.
spent,
Spent
yes, spent catalyst. Because you know it is circulating. Spent catalyst from the reactor enter to the regenerator. See here, okay, you write fast because write fast. Okay.
Okay, doctor.
Now, one thing I would like to inform that here in the first position, the first term, I actually write here in my slides. Please correct that last. Okay, instead of okay, I actually mention everything. Now, why actually? Why? How I found this uh, uh, error in the book itself? See, as I told, that CP value for catalyst or and see CP value for air in two different units. Am I right? Is given. Class?
Yes,
Yes.
doctor.
See, in the CP catalyst value is given kilojoule per kg, but here is given kilojoule per kilomole. So if you put the in the equation, whatever the equation given in the textbook itself, in partly you will find you will do it is not uniform unit. It will be kilojoule per kg and somewhere kilojoule per kilomole. So that is why I have corrected this equation and you have to follow the equation as it is. For example, if you see uh, the first equation or in the book itself, how it is mentioned, if you put the unit, first term, you will found that kilojoule per kilomole, but for second term, you will found kilogram per hour. Something you will find like that. It will be not matching uniform. So we have to follow this equation. Now another thing while I type, I cannot type on the that here n here I write n here. Actually in the book also it is in the book itself it is mentioned m here, but actually it should be molar rate or mass flow rate. M stands for mass flow rate, n stands for actually on the top should be on the one dot should be, but I cannot type. So you please write on the top n on the top dot, meaning that molar rate. M dot meaning that mass flow rate. Everywhere you have to correct it. M here M normally we understand that M stands for mass, but when M dot or N dot that stands for rate. So you have to correct accordingly. Is it clear so far, class?
Yes, doctor.
Please accordingly you follow, because I cannot write it here in the board itself. I can understand, but I can make you understand, but due to here I cannot. So as I told that n air actually should be n dot air, meaning that here molar rate of air, here mass flow rate of catalyst, here mass flow rate of
You
air,
also, doctor.
all.
The Q also.
No,
The
Q, that is different. Q I will explain. Q actually the heat of coke combustion. Here no dot. This is different term. Only mass flow rate and molar flow rate. You have to consider rate, not weight. Rate. Q coke, that is the heat of coke combustion. You write. Q coke stands for heat of coke combustion. Here, N again, here also will be mass flow rate of CO2. M2 also will be mass flow rate of nitrogen. M cat, M mass flow rate. So everywhere where you see mole and mass, everything is you have to consider as a rate, meaning divided by time. Class again, if the system will be down, meaning that interrupt maybe after 10 minutes it will be lost, then you have to come back again, okay? Because I'm seeing one notification already. Okay, class, so far clear, right?
Yes, doctor.
Good. Now you see here the block, the flow, the labeling. This is the regenerator unit. Yesterday, I have explained that in regenerator, spent catalyst, we are regenerating the catalyst, and after regeneration, the regenerated catalyst enter to the reactor, and spent catalyst coming back to reactor. This is a continuous process. Combustion occurring by applying heat. Heat, see here in generator, yesterday I have shown you that added heat, air. So combustion mainly we are doing carbon combustion. Carbon means coke. Coke is a that this carbonaceous material. So we have to combust that. So air enter at 200 degrees centigrade. Outlet, actually this is the flue gas to capture the heat recovered. So flue gas temperature here. So another thing, the PAR stands for the air temperature is 200 degrees centigrade. P regenerated, meaning that flue gas temperature that is 700 degrees centigrade. Mass flow rate and M mass flow rate of nitrogen, mass flow rate of carbon dioxide, we have to calculate. So another term is here entering the, as we know that spent catalyst from regenerator enter to the spent catalyst from reactor enter to the regenerator. MS, S stands for spent catalyst. M coke stands for it's already clear that is the mass, but here is mass, MS or M coke, all this you have to consider as a rate. Mass flow rate of spent catalyst, mass flow rate of coke. Yeah, enter to the regenerator, right? As we know that spent catalyst from reactor enter to the regenerator for regenerating. Outlet from the regenerator, that is MCAT. Actually, this is the regenerated catalyst after the coke combustion. The regenerated catalyst temperature is 690. Enter to the reactor. So here, how many streams are entering? One is air, one is spent catalyst, another one is coke. These are the three streams are entered. Outlet, that is the flue gas and the regenerated catalyst. From the regenerated to the reactor. So now, see, first things what we have to do, that mass, see here, another thing, the unit, all the heat capacity units are given in SI unit, joule, kilojoule, or kilogram. So it is given in SI unit. But mass flow rate is given, data is actually this data will be provided. This one also will be given. So mass flow rate is given 29,813 pound per hour. So it is in American system. So we have to convert to SI system because here CP value, all CP values given in SI unit. So first, the conversion factor will be given, as you know, that the conversion 1 pound equal to 0.4536. Please, everyone has to take now exercise book. I will ask you your answer from your side. So conversion is given 1 pound equal to 0.4536. So now definitely you can calculate pound per hour to kilogram per hour. Please do that. Ariana, are you hearing me? Ariana? Ariana? Ariana, are you not hearing me? Okay, Elisandra, are you hearing me? Elisandra? Elisandra?
Yes, doctor.
Good. Okay, Elisandra, please tell me what your answer you got? Mass flow rate of coke.
Wait, doctor.
Okay. Please, everyone have to do. I will ask you now question one by one.
Uh, convert to kilogram ba, kan dokter?
Yes, kilogram per hour. Conversion rate, conversion table, that is 1 pound equal to 0.4536 kilogram.
Is it 13522 kilogram per hour?
Exactly 13523. Actually, I got
Yeah.
13523.18.
Yeah.
Okay, that is kilogram per hour. Good. So we calculate in SI unit mass flow rate of coke. Second, if I want to calculate molar flow rate, what I should do, Elisandra?
Yes, doctor. Molar flow
Now,
rate.
now you have mass flow rate, right?
Yeah.
Now,
Yes.
if I want to calculate molar flow rate, how can I calculate molar flow rate?
Molar flow rate divide by the molecular weight. Divide by the molecular weight.
Yes, you are right. Because molar rate N equal to M over M2. Now, coke molecular weight
Yes.
is 12. Molecular weight is 12, right? 12,
Yes.
12, letters, because it is in kilo, all this in kilo. So 12 gram mole per mole per, so molecular weight will be 12, uh, 12 gram per mole or 12 kilojoule per kilomole. Right? Am I right?
Yes. Yes,
Okay.
doctor.
Now tell me, what is the molar flow rate of coke?
1126.
Very good. 1126.93 actually I got. You may
Yes.
correct it. So
Yes.
what will be the unit?
Kilomole per hour.
Hour. Very good. Very good. Okay. Now, okay. Until this is clear. Now, that we have to calculate the Q coke. That is Q, as I told, that heat of coke combustion. So here you see the heat of combustion is given negative 0.393. Heat of combustion is given, and heat of uh, uh, heat of now you have calculated the molar flow rate. So now actually Q value you have to just here apply our knowledge that since you have already calculated the molar flow rate and you know the heat of combustion is given, so actually negative heat of combustion always is in the reference you will find that it is in negative sign, but when you do the calculation we will not consider this, so we will take positive. So Q value will be 0.393 times 10 to the power 6 times the molar flow rate, whatever we have calculated just now, 1126.93. Please do that. Have you done that? Anyone?